Python is an excellent language for data analysis, machine learning, artificial intelligence, or general purpose programming. In this video, let's understand how to install Python, Visual Studio Code, set up Jupyter Notebooks, and make your very first Python programs to build that confidence. Welcome to Python for Beginners. Let's go. Start by going to code.visualstudio.com and download the free Visual Studio Code software. This software helps you build Python code as well as many other types of code, test it, run it, and understand Python. So use this link, download for Windows. This is also available for Mac. So whatever platform you're using, download it for that. As you can see here, this tool, Visual Studio Code, helps us build coding for Python, Java, C++, C#, and many other things. So this is a one-stop program that you would want to install if you want to learn data analysis coding. Let's install this software now. A quick note about my computer, I am using Windows 10. So if you are using a different operating system such as Windows 11 or an older version of Windows, some of these screens and download processes will be different. Obviously, if you're using Mac, then it will be completely different. Let's accept this license and let's set up a path. I'm going to install this on my J drive. Let's set this up. Okay, so now our Visual Studio Code has been installed. It does require a restart because I've enabled path variable, but we're going to worry about that later. For now, I'm going to hit on this finish button and open the VS Code file. So here is the Visual Studio Code. You'll notice that it has opened some of my previous Python workbooks or notebooks already, but ignore them for a while because I had this software previously on my computer and I uninstalled it so that I can show you the whole process. For you, when you install, you will get some sort of a release notes page with this kind of a thing. As of recording this video in November 2024, the latest version is October 2024 version, and that's what I'm seeing here. Once this is there, we'll need to install Python as well and set up a data analytics environment in our computer in order to use Python and build some data analysis related coding with that. As I have uninstalled everything related to it, I won't even be able to run most of this code that is already there. Don't worry about what this code is. So for now, we will figure out how to install Python into Visual Studio Code. So now that we have got Visual Studio Code installed, let's go ahead and get Python. Visit the website python.org/downloads. I'll have a link to that in the video description, and use the download option here to download. You can also go to the downloads page to access more download options. Just a quick note, download it for your operating system, and the version of Python that you will install depend on which point in time you're watching this. I'm recording this in November 2024, and as of that time, this is the latest version. So I'm going to download this and install that. It'll give you some options. I'm going to go to custom installation because I don't want to install Python on my C drive. We're going to keep everything selected as is. The installation location, I'm going to change this. You don't have to change this if you're happy to leave it in this current location. It's just that I don't have enough space on my C drive. So I'm going to move it to the J drive where I'm installing rest of the stuff. The next thing is make sure that you're checking all these 5 options, the first 5 options and the advanced options. Again, depending on when you're watching this video, some of these options might change, but for now I'm going to install it for everybody and add Python to environment variables. What this does is it makes sure that your Windows knows where Python is on your computer. So once this is there, I'm going to hit on this install button. All right, our setup is now successful. We have got Python installed. Close this and jump back into Visual Studio Code now. So now that we are here, let's quickly understand what is Visual Studio Code and how to get Python here and how to set up some of the stuff that is needed in order for us to use Python here correctly. Visual Studio Code is an IDE. It stands for Integrated Development Environment, and we can use this to build code, see the results, test if our software is working properly or not, and work in teams and collaborate with others. We are going to use Visual Studio Code to learn Python. So the first thing that you want to do is set up a folder where all your Python experimentation learning will go in. You can see that I already have a pandas experiments folder here, but I'm going to set up a brand new folder so we can all go through this together. To do this, you can go to your computer, set up a folder in your My Documents or wherever you keep your code. For example, here I have got a Python folder, and I'm going to create a new folder here and then name this as Learning Python. So this is the folder that we want to map to Visual Studio Code so that we know that this is where all our files and anything else that we want to work with is going to sit. Now let's open this folder. To do that, we are going to go into File menu and click on Open Folder. Almost everything in Visual Studio Code has these additional shortcuts attached to that. I'm completely new to Visual Studio Code just like you are, so I'm not familiar with most of these shortcuts. I'm going to click on Open Folder and select Learning Python as my folder and click on Select Folder here. So now that's going to create a new kind of like a session for us or new thing for us in Visual Studio Code and maps this folder here. And then it gives us all of these kind of welcome options like create a new file, open that file, open another folder, connect to, and some of the recent stuff here. Let's add a new file. You can click on this button, file plus icon here. You'll also see that same thing here, new file there. So I'm going to click on this and then I'm going to say our first Python code.py. We use the .py as the extension for all Python related coding files, and that way our computer knows that these are Python codes. And here we just want to, for example, print a message like hello or something like that. This is usually the very first thing any programming tutorials will teach you, how to print a hello message. So we are going to say print open brackets and in double quotes, hello, this is my first Python code. And that's it. Once you write that, you'll see that as you're writing, the help and everything is coming in nicely. To run that, we'll need to use this. But in order to run that, we'll need to actually tell Visual Studio where our Python is and set up a environment as well. But for now, let's try to run this and see what happens. When you run it, as we have already successfully installed Python, you will see the output here. Hello, this is my first Python code in the terminal. Terminal is basically where all the outputs are printed, and you'll see that it is using the Python that we have set up. Now that we have Python installed and we are able to see the results in the code area here, let's go ahead and set up what is called a virtual environment. Think of virtual environment like this. If this is your computer, we already have Python installed on it. So this is Python. For now, the way we are using it is, this is my Hello World program. It just directly talks to Python and gets the results. As you start building more and more code, you will create multiple files, each doing its own thing. And sometimes you may want to kind of ring fence them into a separate area so that all the related stuff for this is also maintained here in a separate area. And we can think of this as one environment. Like that, you can have different environments. So each of these big boxes are one environment. This is my learning environment. That could be my data analysis project environment. This could be some shopping cart analysis or machine learning environment like that. Each environment deals with all the related stuff for Python and kind of self-contains it there so that everything happens easily for us. So that's what a virtual environment is. It is kind of like a foreign concept, especially if you have not done any coding or software development. But once you start using it, all makes sense. So let's go ahead and create the virtual environment. To do that, you want to click on this little search area up top. This is like the generic search area. All the searches that you do happen here directly. But you want to click on that, and instead of going to file, select the show and run commands option. You can also access this using Control-Shift-P. But like I said, I'm also new to Visual Studio Code, so I don't really know most of these shortcuts. So once you're here, search for create environment, and you will find Python create environment option. Let's tap on that. There are two options here, venv and conda. We are going to use venv or virtual environment in the current workspace. What this does is it basically creates an environment for us. It will ask you which Python interpreter you want to use. We only have one interpreter on our J drive, but if you are somebody who has been installing Python multiple times on your computer, for whatever reason, you may have to pick the one that you want to use for that project. So here I'm going to just select this one, and you'll see at the bottom the environment creation process is happening, and when it finishes it will also have a .venv folder in our learning Python space. So now the environment setup is done, and you can kind of see that here. Like I said, what environment is, I'll show you here in the folder as well. It's basically a self-contained space for Python to hold all the relevant libraries and scripts and other things that it needs. After we create our environment, we'll need to select it so that we can use that going forward. To do that, again, you can click on this search bar and use the show and run commands option and type in select interpreter and use the Python select interpreter option. And from here, you'll see that it has already recommended our environment Python rather than the JPython installation location. So now onwards, going forward, we want to use this interpreter for Python. Don't worry too much about it. What we have done through environment is we have kind of created an isolated area for Python, and going forward, we are telling Visual Studio Code that use the isolated areas Python to run everything. So I'm gonna select that. And now that that is set, we'll need to reset our terminal because our terminal still thinks Python is at J drive, whereas we want to now use the new environments Python. You'll see that as a warning here in the terminal as well. It is saying the following extensions want to relaunch the terminal to contribute to its environment. So I'm going to go here and click on relaunch terminal, and that basically kind of clears it for us and opens it as if we are now using the environment. Now let's run the code again. You can just place your cursor there and use the run, and again same result. Hello, this is my first Python code. So far we have set up Visual Studio Code, installed Python, and created our very first Python code as well as set up a virtual environment. We'll do just two more things before we start building our first data analysis coding with Python. And that is to install some extensions to help us in the process of building the code. The two main extensions that you need are Python for Visual Studio as well as the Jupyter Notebooks extension. Both of these can be found in the extensions area of Visual Studio Code. You can see here we are currently in the Explorer area. From there, go into extensions. And here you can find those extensions. I already have these installed, but I'm going to show you how to install them. So use the search option here and search for Python, and you will find the Python extension. This is from Microsoft itself. You can see that I already have it installed. So my option here is uninstall, but you would want to install this. This helps you write code easily because it offers a lot more support for Python building. And it also installs some other additional extensions like Python debugger, etc. We are not going to use them right now, but they will help you later when you start learning more about coding. The next extension that you want to install is the Jupyter. So search for that, and again you will find that Jupyter Notebook support and install that. Both of these are from Microsoft itself, and just install them, and that will help you later when we start using Python for data analysis. I'll explain what these are and how to use them once we start coding. So now that we have got Visual Studio and all the extensions installed, let's start programming in Python. Let's start by opening Visual Studio. And this should either open a blank screen like this, or it should open the folder that we have already set up. In your case, it might already open the Learn Python folder. So as it is opening a blank screen for me, I'm going to click on this open folder, go to the Learn Python and select this folder. This will show the Learning Python in the Explorer area here and our very first Python code.py. This is the file that we had created in the previous examples where we are just saying hello. In this lesson, let's understand how to create our very first Jupyter notebook and use the notebook style programming to learn and understand Python. To do this, you must have the Jupyter extension installed in Visual Studio. If you have not already done it, you can go into the extensions area here, search for Jupyter and install this particular add-in. This extension or add-in helps you write notebook style coding. I'll explain what this is in a minute, but you must have this installed. Then while in the Explorer area here, you can click on the search bar and use the show and run commands option. In fact, this is something that you would be doing quite often. So you might as well remember the shortcut for this, which is Ctrl+Shift+P. And use the Jupyter as the search option and find new Jupyter notebook option here. You can only use it once the extension is installed. This is going to create a untitled notebook for you. A notebook is where normally when you are learning or doing data analysis, data science or machine learning in Python, we use this kind of notebook style programming. What a notebook does is, instead of the traditional way of coding is like this. I'm going to draw a line here. So on the left hand side is my traditional style of coding, and this is how that works. Usually we write a big piece of code and then we run it and then we see the output in a terminal. This is how we have done it for our hello, welcome to Python kind of a program. We wrote a print statement, we ran it, and we saw the output here in the output window. What notebook style programming does is, instead of waiting for the entire code to be written and then executed, it introduces a different dynamic. So a notebook would have basically cells. So you'd have a cell where you will write some code and then you will run that cell and the output will be immediately printed underneath. And then you'll write one more cell, run that, and output will be printed underneath. This kind of a style is helpful for doing data analysis, machine learning, data science, and even learning programming. Because this way you don't have to wait for the whole thing to be done. Instead, you can write a couple of lines of code, execute them, see the results, make sure that you're on the right track, and then continue writing. So this thing is called notebook style programming, and Jupyter is one of the popular ways of building that. So when you create a Jupyter notebook, it gives you this sort of a setup for you. Apart from the code and output cells, you'll also have a special type of a cell called markdown cells. What a markdown is essentially for you to write some notes or titles or document the code as you're writing. So we are going to use this to build our first examples of Python, and along way you'll feel comfortable with this. Going forward, we'll use this for pretty much all of our Python exploration. So here I have created a untitled file. I'm going to Ctrl+S to save this first, my first Python examples, and then save it. So here, usually whenever you create a notebook, the first cell will always be added, and this is where you can kind of write your first code. Instead of starting with a code cell, I'm going to turn this into a markdown cell. Markdown cells are where you can just write stuff, and for that you can right click on it, click on notebook cell, and use the change cell to markdown option. You can also press the key M to change this, and this is basically a markdown cell, and you can just type anything here. So our first objective is to create a student. So let's create a student data in Python. So imagine you are running an online course like this and you want to enter some student information and maintain it. So this is the objective for us, and then we can use this plus buttons to either add a code block or a markdown block. So I'm going to add a code block, and here for a student, obviously they'll have a name, and the name will be equal to, in this case, we can say the name is Alice. And then we can also maintain their age. Let's say Alice is 18 years old. And we can also maintain their GPA. Let's say Alice GPA is 3.78. And we also want to maintain some additional information like whether Alice is playing volleyball or not. So we can say plays volleyball. So if you have already used Excel or other kinds of things, you are familiar with this style of maintaining information. You usually have a variable. Variable is where name is a variable and it holds this value as Alice. So we have used this concept in Excel, in SQL, in Power BI, elsewhere, pretty much all the places where you're using technology. This sort of a idea is similar. So we have created 4 variables. And if you just run this code block here, it's gonna ask you to pick an environment. I'm gonna click on the environment and select our virtual environment that we have set up earlier. So remember, it is now in our Learning Python module. And once you map the environment, you will also see the code is actually neatly colored and text values are in this color and numbers are in this color. And the true is actually underlined. True is not defined. So obviously this is an error. And if you don't know, you can hover and then you can use the quick fix here and you can kind of see this, but I think we are meant to use capital T there. That's the problem. And once you fix that error, you can run this and it will ask you, so running cells with virtual environment requires IP kernel package. Do you want to install it? So as we haven't initially used the Jupyter at all, it is asking us to install some things. This is quite normal. You can install it, and whatever you install, they will all be contained into the virtual environment that you have set up. So I'm going to install this, and we can see the status of that here. It will take a while for this installation to complete. And once it is done, you will see a green tick here saying success. This code is executed. Now, unfortunately, even though we have created a student, there is no way for us to see that this student exists in our system. So we would like to actually print this. You can again edit the code, or you can add one more cell and do that. As this is all one part of the puzzle, I'm just going to edit it. You can just place your cursor inside and hit enter. And let's print the name of the student that we have created. For this, we can use the print function, print open bracket, and then simply say name. And the name of the student will be printed. When you run this, you'll see that that code block has finished execution and the output will be printed immediately. Once you have done that, you can add more code here. One of the most useful and powerful functions of Python is the like function. I'm kidding. There's no like function in Python, hopefully. But there is a like function on YouTube. So if you're enjoying this video so far, give it a like and share it with some of your friends. It really helps me. Now let's go on. So for example, instead of just printing the name, I would like to print their entire record or all the information for that student. So I'm going to add one more code block, and this time I'm going to say print name, comma, age, comma, GPA. And as you're typing, you'll see that the IntelliSense or auto suggest actually comes up, and it's quite helpful. You can just select that, and then I want to select plays volleyball as well. And you can just run that and you will get all the information that you're holding about Alice here. Let's say Alice has completed a few more examinations and now her GPA has changed. We can add more code block here and then say GPA is equal to now no longer it's 3.78, it's 3.85. So this is basically how you work with variables. You create a variable by just setting the name and equal to and some value to it. When you do it for the first time, the variable GPA will be created. Think of variable like a tiny place where some information is held. And when you change it, you can kind of say a new value. You can also, instead of just saying new value like this, you can say an expression. So for example, GPA is 3.85. Instead of directly typing that, I can say GPA is equal to GPA plus. So the prior GPA went up by 0.07. So you can do in either way, and when you run this again, that will update the GPA calculation. You can print the new GPA here. You can just say print, and instead of doing the whole thing, I'm just going to copy, open bracket, and then run it, and now you'll get the new GPA here as that. That number doesn't make sense. I was thinking it's going to be 3.85, but we are getting something like 3.92. This is because when I first set this GPA is equal to GPA plus 0.07, I ran the code block once. So the GPA has already gone up to 3.85. The next time we added this print statement and now we are running it again. So this time it is going up by another 0.07 and that's why we are getting that as the result. So in order to see the correct GPA, what we need to now do is run all the code cells again. So instead of running this one alone, we'll need to execute all the code cells above as well. So this is the option that you want to use. And what that does is it will first run these two. And now if I run that, I'll get the 3.8499 or 85 really. So this is one way, but if you look at this information here, it kind of looks a little bit clumsy. I would like to, instead of saying this, maybe print a more meaningful sentence. So let's add a markdown here. Let's try and print the student information in a more meaningful manner. And to do that, we are going to use the same print function, but this time we are going to use a special concept called f strings. This is a special aspect of Python where we use f, and then within double quotes you can write a sentence that will be printed. So for example, here I can say f, the student name is, and then curly brackets name, and they are age years old. So what this will do is it will kind of construct a sentence. There are some fixed parts of the sentence, the student name is, and where the curly brackets are, it will bring in the variable name, and age, again the variable will come in here. And when I run this, I'll get this beautiful sentence here that says student name is Alice and they are 18 years old. You can use the same f strings to print more meaningful sentences or generate outputs that will help you later as part of doing some other work. When you have a Jupyter notebook here, you'll see that in the output area of Visual Studio Code, there is also a Jupyter tab, and you can use that to kind of inspect all the variables and all the data that currently is maintained in this notebook. So if you go to the Jupyter, you will see all the names and their current values. So for example, age is 18, GPA is right now 3.85, name is Alice and it has a size of 5, and place volleyball is true. You'll also see that there is a type column here that tells us what is the data type that Python is using to store these values. So age is maintained as an integer, GPA is a floating point value, name is str or string, and place volleyball is a Boolean value. So it can only be true or false. And these are kind of internally created by Python automatically the moment you create those variables. So now that we have some information and some way to look at this data, let's do something interesting. Let's calculate what is the age of Alice, how old she would be in 15 years. So again, I'm going to add a markdown, and here in the markdown, I'm going to say, let's calculate Alice's age in 15 years. Now to do this, what is the logic that we need to follow? We already know what her age is. In 15 more years, she'll be that age plus 15. So we'll say age would be in 15 years, age plus 15. And then we can print the same thing. I'm just going to copy this and paste it there. So student name is Alice and they will be in 15 years. So that's the thing. You can see that in this expression here, we are using a simple arithmetic operation of plus. Just as you're using plus, you can use minus, you can use multiplication, you can also use the division sign to do standard arithmetic operations. So in this case, a plus is what we will use. Again, most of these operations are similar to how we would do things in Excel, SQL, or Power BI, or any other system. So I'm not over explaining them, but there are a whole bunch of operators that you can use that kind of just make sense. So let's run this again. And the student name is Alice and they will be 33 years old in 15 years. And you can see that as soon as I ran this, in my Jupyter tab of the console, the age variable went up to 33. So this is what the Jupyter tab allows you to see. It kind of lets you peek into the values of things as they're happening, as the code execution is going down the notebook. Keep in mind that in notebook style programming like this, the results of various cells depend on what happened prior to that. So for example, if I wanted to run this directly, but let's say I have not ran any of the previous things, I might get some errors. To kind of mimic that, what I'll do is I will first try to clear this. I'm going to save this notebook and then close this. Now let's double click on the my first Python examples IPYNB, the notebook, and open this again. Now, as of now, if I go to my Jupyter tab, there are no variables. So it has no idea about Alice or any of the information that we are maintaining it. And let's say if I run this block directly without executing any of the previous blocks, then I'll start getting some sort of weird error. So for example, here, age is equal to age plus 15. The name age is not defined. So Python has no idea what this age is to begin with, and hence it cannot run. So this is an important thing to keep in mind with notebook style programming. In notebook style programming, as you will have various blocks, and sometimes there will be a hidden order required. So this block needs to run before that can run. Likewise, this block needs to run before that can run. So there is some sort of a dependency there, and you just can't run an individual block directly. You must actually execute everything before, or most of the things before, to see the correct results here. To fix this error, what we are gonna do is we'll need to run everything before. You can either use the run all button here, which will kind of run everything in a sequential order, or when you are looking at a block, the code block here, you can use this button, execute all the above cells to execute them. So it all depends on how you want to do it. I'm just gonna say run all there, and that will basically clear out the errors for us, and it will give you the answer. And again, our variables are now looking just like the way they are. The next concept that we want to learn is lists and other types of data structures in Python. Now, when you are maintaining information, let's say the information about a student like Alice, this sort of a structure might work, but it is also a little bit cumbersome. Let's take a closer look at the place volleyball option. Right now, she is playing only one sport, so place volleyball is true or false. But what if Alice is one of those really energetic students and she likes to play a whole bunch of different sports? So maybe she likes to play volleyball, hockey, rugby, and cricket, and many other things. In that case, you need to maintain different variables, one for each sport, and that can look a bit confusing and complicated. So you could also use a special type of a data structure called a list. A list is just a bunch of values, and say that, sports played by Alice is equal to, and then all these items that she's involved in. So let's try to create that. I'm going to create a code block here and paste that. So sports is equal to, and then within square brackets, we are just going to list all the sports in which she is involved in. So she's playing volleyball, netball, touch rugby, and cross country. This is how you create a list in Python. A list is basically a collection of values. So in a way, if you have used Excel, then a list is basically a range of cells. If you have used SQL, a list is nothing but like a table column or something like that. And in other places. So we kind of see these things all the way in life in different walks. So I don't want to over explain this. So now that these are all the sports that she's playing, I want to know what is the first sport she's playing in. So I'm going to use sports, open bracket, 1. And let's execute this. If you just say something without actually writing print, then that will be executed and the output will also be printed down here. So let's see this, and we'll get the output as netball. Now I was thinking it's going to say volleyball because that's the first sport that she's playing. But Python tells me sports of 1 is actually netball. This is because Python uses zero indexation. What it means is whenever you have a list or a collection of items, they can be anything really, they always have 0 as the first item, 1, 2, 3 like that. In fact, you are familiar with this concept in Power Query as well. Within Power Query, the items begin with the 0th item. So the first item is called 0th item. So if you really want to see what is the first sport that Alice is playing, you should say sports of 0 instead of 1. So let's modify this code. I'm going to change this to 0 and then run it again. And this time we'll see that as volleyball. Let's take a closer look at our variables here. You'll see that the sports is actually a type of list. So now we are seeing a different data type here, and it has a size of 4, and these are all the items. Now, like I said, Alice is a really athletic person, so she likes to get involved in different things. So let's say next year she would like to enroll into the cricket team. That means the list of sports that she's playing is no longer 4, but we would like to add one more to it. So this is where, when you have a special data type like list, you have additional functions or things that you can do on top of things. So we would like to add sport of cricket to her list of things. And this is where you can use the append option, append, and then you can specify what you want to append. We want to append cricket to this list. And let's print the updated list of Alice's sports. So we can use print and then say something like this. Alice is currently playing semicolon and then comma sports. So let's see all of this. This is the current list: volleyball, netball, touch rugby, cross country, and cricket. When we have lists like this, you can use a number like 0, sports of 0, to select just the individual one item. But sometimes you may want to select more than one item. So for example, I may want to select volleyball, netball, and touch rugby, and then see those three things, like these are the first 3 sports that she's involved in. So in that case, we can also use an operation called slicing. This is how it works. We'll say sports, open bracket, and then starting number 0, and then ending number 3. Now, when you do it like this, what it will do is it will give you the items 0, 1, and 2. So third item, or in fact, fourth item is not included. It will start from 0 and then it will go up to 3, but not the third one. So when you do it like this, you'll get volleyball, netball, and touch rugby like that. Again, this kind of a slicing is similar to how we access a bunch of items in Excel as well. If I want to get items from A1 to A3, I would say A1, A3 like that, and we will get it. As Excel is not 0 indexed, the behavior is slightly different. But all in all, this is pretty much how the list slicing options work in Python. Let's say this is all fine, but you don't want to see the first 3 items. Instead of these 3 items, you would want to see these 3 items. So that means from the last, I want to see the 3 items: touch rugby, cross country, and cricket. How would you do that? Give it a go and leave a comment with your response. This is a homework, but I'll now show you my answer. I'm going to add a markdown here. And when you are adding these markdowns, you may want to, for example, emphasize certain things. As this is focusing on just the last 3 sports, I would like to highlight this phrase, last 3 sports, in bold. What you can do is you can use some special operators when creating this markdown. So for example, if you replace that with star star, last 3 sports, star star, it tells Jupyter that you want this to be in bold. And when you add that, you will see that that is highlighted in bold formatting. Likewise, there are many options. So for example, if you put a single star, that's going to italicize that and you will get that kind of a thing. Let's go with bold formatting. For this, we need to understand negative indexing. If I just use sports -1, what this does is it will give me the very last sport she's playing. So for example, -1 here would be cricket because that's the last sport that we have in the list. Likewise, if I just say -2, I'll have cross country. Now, in our case, we want to go from -3 all the way to the end. So this is where if I simply say -3 and then colon, and then I just don't say the end point, what that does is it tells Python that you want everything from the last 3rd item all the way until the end. So you'll get touch rugby, cross country, and cricket. You can use this notation even for other kinds of things. So for example, you can simply say sports, and let's say I want to see everything from the 2nd sport. I can just say 2 like this, and then we will get touch rugby, cross country, and cricket. Here again, I have a reminder that Python is 0 indexed. So if I say 2, I'm actually referring to the 3rd item in the list. So if I want everything from the 2nd item, I'll need to say 1 as 1 like that. and then I'll get everything from the second spot onwards. There is a lot of complicated and variety syntaxes available here, and it does take a while to get used to this way of looking at lists. So I'll suggest practicing this a little bit more as you learn Python. Let's conclude this segment by building a simple letter grade calculator for our students. So I'm going to add a markdown, and here we want to say calculating letter grade. As this is a new topic, I want to make this a heading. For this, you can use either hashtag, which will be heading 1, or 2 hashtags for heading 2. So I'm going to use this calculating letter grade and add that, and that will be like a big heading in my notebook. So I know that I'm switching to a different topic. I'm just going to edit this again and define the logic as well. The logic is basically like this. So we're going to create this as a bullet point. To create a bullet point, you can just type hyphen and then type the list of items. So anything 2 or under is D grade, 3 or under is C, 3.8 or under is B, above 3.8 A grade. Let's add this markdown, and you will now see calculating letter grade with these bullet points here. This kind of tells us what is the objective that we are going to go for. Initially, we will try to do this just for Alice, but later we will build more complicated logic where I can take an input, like I can ask the program will ask you what is the GPA, and then it will convert that into a letter grade using these 4-step logic. For us to do this, we'll need to understand how to use if statements in Python. So let's start with the code. We already have the GPA as a variable here. You can see GPA is currently 3.8499 or 85, and we will use that to calculate. And so in this case, Alice should be getting letter grade A because it is above 3.8. So here we will build that if logic. If and GPA is greater than or equal to, and instead of directly using the GPA variable, I'm going to make a small change here. Oops, I pressed enter and that code block ran. So I'm just going to edit this, and let's just clear this output as well. So instead of directly using the if GPA like that, I'm going to create a new variable called student underscore GPA and then assign the GPA variable to that. And going forward, we will refer the student GPA variable. You will understand why we are doing this after a few minutes. But for now, if student GPA is greater than or equal to 3.8, and then we use colon to indicate that this is the condition, and the output would be you press enter and then it will automatically indent. So this is one of the unique things with Python. It will actually use indentation to tell. So the indentation is basically things moved in to tell what is it that should happen inside this if statement. Now, if you have done any programming in other software, even with Excel if function, you'll understand that this is slightly different than how things happen elsewhere. But this is one of those nuances of Python that you will eventually get used to. So here, if student GPA is greater than or equal to 3.8, then we will say letter grade, and we'll say letter grade is equal to A in double quotes. I think we can also use single quotes, but we'll just use double quotes for this. Then I'll hit enter, go back, and then test for the next condition, because we have got 4 conditions here, and we are doing it the other way around. Actually, what I'm going to do is I'll follow the same structure as this bullet points. So I'm going to build the conditions from under. So I'll say 2 less than or equal to, and then number 2, then this would be D, and then we are going to use the elif, which is basically else if, and then student GPA less than or equal to 3, letter grade is equal to C, elif student GPA less than or equal to 3.8, letter grade is equal to B, else, that means we have completed all the checks. Now the letter grade should be A. And now that the letter grade is calculated, we'll go back, and here we are just going to print students, and we are going to use a F function for this, F string for this, students letter grade is, and then use the letter grade variable like that. So this is a very simple control structure where we are saying if the GPA is less than 2, then it is D, 3 is C, 3.8 is B, else it is A. And it's kind of similar to how you would build this sort of a if condition logic in any programming or any technical system really. But the thing to keep in mind with Python is this sort of a indentation business, and how we use this colon to indicate that we have written the condition and now we want to jump into the indentation bits. So let's run this, and we will get student's letter grade is A as the option, because remember the GPA is 3.84999, which is more than all of these things. So obviously this is what we are going to get that as an answer. Now, like I said, this only works for Alice, but we would like to actually extend this and make sure that it works for anybody. So rather than using Alice's value, we are going to now convert this into a calculator. For that, what we will do is we will ask the user, whoever is using this program, to enter their GPA, and then it will tell you what the letter grade is. So instead of using GPA, I'm going to use a function called input. And what input does is, just like you have got print, which prints output on the screen, input will ask you for an input value. So input, open bracket, and then we're gonna put a statement here that says, what is your GPA ? And when you run this, what this will do is the program or Python here will stop and wait for you to give the input. Now, the way this works depends on how you're running this code. In Visual Studio Code, when you're using Jupyter, this works one way. But if you write it as a Python code, it works slightly different. That is where you enter the input. I'll explain that in a minute. For now, I'm going to run this. And when you run in Visual Studio Code, it will open this box up top asking you to enter the grade point. So this is basically, at this point, the program is waiting for you to give the input. So nothing will happen. You'll see that this timer keeps going up because it's waiting on you. So here I'm going to come in and then type the grade point as 2.76 and hit enter. And at this point, we are supposed to get the value, but we are getting an error. The error is happening because here it is telling me that less than or equal to not supported between instances of string and integer. Now, this is because I think the input function, whatever you are gathering as input, that comes to you as a string variable. So student GPA here, if you see this variable here, Python thinks it is a string. Whereas the comparison we are doing it is against a number. So a string cannot be compared to a number. This is where the problem is. So to fix that, what we will need to do is we'll need to take that input and turn that into a floating point number. So to do that, we will take the input and then we will convert that into a float by using another function called float. Float of input. Essentially what this does is it's basically nesting things. So first the input will run. It will collect the input of 2.76 or whatever you're typing, and then it will try to convert that into a floating value and then puts that into student GPA. So let's run this again. Again, a reminder, the input will have to go in up top here. So here I'm going to type 2.76. And now student GPA is calculated correctly and we'll get their letter grade as C because it is less than or equal to 3, but it is not less than or equal to 2. So in this case, this is the condition that works out and we will get the output as C. You'll also see in the Jupyter area of the console, this one here, student GPA, now the data type for that is set as float. You can nest the functions like this, or you can take the input into one variable and create another variable to convert that into float as well, whatever works for you. But this is how you can use the type conversion or typecasting functions like float to convert one data type to another, because usually input is always coming back as a string. So now that this is working, let's test this out a few more times. I'm going to execute this once again. This time let's set someone as 1.95 and we will get their letter grade as a D. Let's test someone with 4.23. and we will get the letter grade as A. So far in this video, you understood how to install Python, how to set up Visual Studio Code, how to create your very first Jupyter Notebooks, how to use virtual environments, and how to build your first Python examples. In the subsequent parts of this video, we are going to understand how to use loops, list comprehensions, and how to work with packages like numpy and matplotlib to analyze the data and visualize the results. I'll catch you in those videos. For more updates on all my Python as well as data analysis videos, feel free to subscribe to my channel and follow it. If you enjoyed this video so far, don't forget to like it and share it with some of your friends. I wish you all the best in your Python learning journey, and I'll catch you out there. Bye.